Doing module 6, chapter 2. So we are talking about multiplying fractions and whole numbers. So you use our counters in order to represent our multiplication of fractions and whole numbers. Now today we are using fraction strips. So we're going to use it to help us understand a little bit further and kind of get that step on the ground where we're going to actually start doing the math, and we will eventually do a anchor chart to represent what is happening when it comes to both the model and the math. Okay, so first of all, Martin is planting a vegetable garden. Each row is 2 meters long. Each row is 2 meters long. He wants to plant carrots along 3/4 of each row. So how much of each row? 3/4. Okay. Okay, 3/4 of each row. So how many meters of each row? How many meters of each row will be planted with carrots? So I know that each row is 2 meters long. I know that 3/4 of each row is going to have carrots. So I need to figure out that amount. So it's not going to be the full. It's not going to be both of the 2 meters, right? It's going to be less than 2 meters, right? Can we all agree on that? We can have 3/4 of each row and still have 2 full meters, right? Because they're 3/4. It's 3 out of the 4 pieces that we're going to break it down into. So I'm going to multiply 3/4 and 2. So I need to have fraction strips, and I need to place 1 whole fraction strips side by side to represent the length of the garden. So that means I'm going to take my fraction strips. The holes are what color? Okay. All right, what color is this? Red. Okay. I need to have 2 holes. I need to have 2 red fraction strips. That is why we are doing it in partners, not individually. Okay. There we go. Okay. I know it's not perfect, but I'm trying to get it as easily seen as possible. Okay. So from here, I need to find 4 fraction strips, all with the same denominator, that fit under 2 holes. I need to find 4 fraction strips, all with the same denominator, that fit exactly under 2 holes. What do you guys think? What would be equal to 2 holes that's made out of 4 fraction strips? Grayson, 4 halves, right? We should have 4 halves. You guys should not hear talking. I should see you moving and working together in your group. So I can also draw a picture of my model. So if you see on the side there, it says to draw a picture of your model, right? So they have it right here, right? So if I add on my halves, I want to add on my halves here. So would I want to look at this and I want to see, is there 3/4 of this that I could take away or that I could circle? What would I circle whenever I have, remember there's four what? Halves. So I need to circle 3 out of those 4. So I'm going to circle, I know it's kind of hard to see, but I'm going to circle 3 of those 4. So what does that give me? If I have 3 halves, what does that give me? Bryce, 1 and a half, right? Whenever I add 3 halves together, I get 1 and a half. So if I complete my number sentence on letter choice E, or not letter choice, but letter E, 3/4 times 2 is equal to what? What do we find out? What was my answer? I know it's glaring, but 1 and a half. So Martin will plant along 1.5 meters of each row. So on your book, go back over here. It's 1.5 in both of these two blanks. So why did we place 4 fraction strips with the same denominator under the 2 one-hole strips? Why does that make sense? Why did I place 4 fraction strips with the same denominator under the 2 whole 1 strips? Lexi. So it needed to be equal, right? But where did I get the 4 from? Where did my 4 come from? Look at my number sentence. Where did my 4 come from? Where did my 4 come from? I didn't just pull it out of nowhere. I didn't pull it out of my brain. I looked at my paper. I saw there was something that was here in my number sentence. Lexi cannot be the only one paying attention right now. Where did I find 4 in my number sentence here? Where is it at? Elizabeth. It's in my denominator. I used my denominator to help me figure out how many fraction strips I needed to have underneath my 2 holes. So I looked at my number sentence. Saw my denominator was 4. And use that to find 4 denominator. Find 4 fraction strips with the same denominator. Okay, so I looked at my number sentence. I saw that there was a 4 in my denominator. And I used that to find 4 fraction strips with the same denominator. It's kind of like what we did yesterday, right? What did the denominator do for me yesterday whenever I had the counters? How did that help me, Grayson? Yeah, the denominator is the bottom number. So what did that do? It shows you how many rows you have. Yes, it showed me how many rows I had or how many groups I had. Same thing here, right? I'm breaking it down into groups so that I can split them up evenly to solve my problem. I'm doing the same exact thing, but with fraction strips instead of counters. Okay? I'm looking at the actual fractions instead of just looking at the numbers themselves. So, how would I model 3/10 of 2? How would I model 3/10 of 2? How would I do that? What do we think, Peyton? Ah, so she has a good idea. So I don't think I have enough stuff for it, but you said 10 what fits? Good. Let's see if I have enough. Okay, so look, I know that one whole is equal to how many fifths? Simple. Remember, every time that I have a whole, my numerator and denominator are what? What happens whenever I have one whole? That means my numerator and denominator are what? What is their relationship? I heard somebody say it, but I want you to raise your hand and tell me. What happens? Come on, Neil. Help me out. Grayson. They're the same, right? So one whole is equal to 5/5, right? So if I need my denominator, right? My denominator was 10 because it's 3/10, right? So if I'm finding 10 out of 2, right? I need to find something out of 10 out of 2. I can have 5 being represented under both of them. So let me see. I think I have enough, but if not, it's okay. And I can draw in the last couple. But I put all the fifths in there. Oh, you have enough. Good. Okay. So look, I now have 10 fifths being represented underneath my two wholes, right? Because my problem itself is 3/10 of 2. So I put the fraction strips on there so that I had 10 pieces, right, total to find that 3/10. So then what would be 3/10 of 2? How would I find 3 of these 10 pieces? I just count them out, right? I count 1, 2, 3. That's 3/10 of the amount of pieces, right? Or how many fifths? So it's 3/5, right? That's the actual fraction. But this is equivalent to 3/10 of the 2. Does that make sense? I know that kind of sounds silly. It's got two different fractions, but it's not the same. I have two wholes, right? And I have 10 pieces, right? Does that make sense? Do we understand that? I have 10 pieces that are equivalent to that two whole. So then I take 3 of those 10, and that fraction of what I start with, so I have 1/5 plus 1/5 plus 1/5 is equal to 3/5, which gives me my answer. So I would model it doing the same thing. So basically, you would kind of rewrite what you said before. So I see that my denominator is 10, and I use that to find 10 equal fraction strips with the same denominator to represent my problem. Okay, so that is how I'm doing. That's how I figure that out. So I find an equal. I find sorry a fraction strip that fit under two holes equally. That has 10 total strips. which is 1/5. So in this case, it's 1/5. I realize that is equal. I apologize. Okay. So I find a fraction strip that fits under two holes equally that has a total of 10 strips. In this case, it's 1/5. Because I looked and I saw my denominator is 10. And that is how I represent. I find one that has the same denominator that I can put 10 pieces. So if you notice, right, I know we only used 2 so far, but what have you noticed? There's a pattern to how we set it up. What's the pattern that we use to set it up? What do I use to help me find how many fraction strips go underneath my whole number? It's very simple. Is it the numerator or the denominator? Which one shows me what I'm doing, how many I'm putting underneath my whole number? Which one? You know? Which one did I use? The denominator, right? My denominator gives me the amount. Think about the groups like yesterday. It gives me the amount of groups, right? So I have to come up with a group that represents the same thing. And then whenever I do that, I can add them together and I can find my final answer. This one's a little bit different. Yesterday we were finding what were my answers every time? Were they fractions or whole numbers? Were my answers whenever I multiplied fractions or whole numbers? Do you remember? On your paper? What? It was whole numbers. But what's different here? They're fractions, right? Because I'm starting with smaller numbers, right? I've added 2 as my whole number. And it would be really hard to get anything much bigger, right? Because remember, my whole number means if it's 2, that means that my answer has to be less than 2 every time. So that means I'm going to have those smaller numbers like 1.5 and 3/5. So whenever I start with those smaller numbers, I'm going to get even smaller numbers, which is why we're using fraction bars for this particular multiplication. Okay? So moving on to the next page. I knew I forgot something today. Okay. So we're not going to use fraction circles because I forgot them in the other room. But I can not right now. Okay. So we're gonna just draw it out because we can draw it out. That's not a big deal. Okay. So Margaret was helping clean up after a class party. There were 3 boxes of remaining pizza in them. Each box had 3/8 of a pizza left. How much pizza was left in all? So what am I doing here? Am I adding or subtracting, first of all? This is a little bit tricky here. It's adding because in all, I am adding. Okay? So I need to find 3 times 3/8. So I'm going to model 3 one-whole fraction circles to represent the boxes containing. So if you see here, it already has them drawn out for you, but I need to shade the fractional amount. So in this case, what was my fraction? What did they tell me it was? What is my fraction? What is my fraction, Kason? Fraction? What's it in my problem? 3/8. So I have them separated into 8s, right? So I need to shade 3 of those 8s in every single one of those circles because remember, it's each of the pizzas had 3/8. So I'm going to shade 1, 2, 3. 1, 2, 3. 1, 2, 3. So each circle shows how many eighths of a whole. Okay. Each circle shows how many eighths of a whole. What do we shade? Melanie. 3/8. So in total, how many eighths are shaded? In total, how many eighths are shaded? Bryce. 9/8. Okay. So in total, there are 9/8 shaded. Whenever I add them together, I get 9/8. But what do I need to do here? Can I leave it like that? What is this right here? What's that called? It is an improper fraction. So what do I need to do in order to change it to a mixed number? I need to rename. So one whole, right? I need to have at least one whole. And then 9 minus 8 gives me what? 1. So I'm left with 1/8. So I have one whole and 1/8. So there was one whole and 1/8 of my boxes of pizzas left. Are we following? I know this this was one of the ones that really the kids that I had last semester really struggled with. So are we following? I'm gonna keep doing more practice because this one is one of those that I feel like is a little bit harder. And we will complete an anchor chart together in just a moment, okay? So 5, 6 times 3. Look, it already has it listed there for you. How do they come up with half here? How do they come up with halves? Why is it halves here? Who can tell me? Well, how many halves are there total? 1, 2, 3, 4, 5, 6. Where did my 6 come from? Where did my 6 come from? Where did my 6 come from? Peyton. My denominator, right? So I had to find fraction strips that were equal, right? They were equal to the 3 wholes, right? I need to find the amount that was equal to the denominator. It had to be equal to 3 wholes, that there were 6 of them. So I know that one whole has 2 halves, right? And if I have I have 3 wholes, then I have 2, 4, 6. So now I circled 5 of those 6. So there are 5 of the 6 fraction bars circled. So I'm going to add those all together. So I'm going to add 1/2 plus 1/2 plus 1/2 plus 1/2 plus 1/2. So 2 halves equal a what? 2 halves equal what? What is 2 halves? 1 whole plus another 1 whole plus a half. So I get 1 plus 1 is 2 and a half. Number 2. Number 2. So I already have it written out for me, right? I have 2 times 5, 6, right? You see that? Okay. So now, just like I did up here, what did I do up here? I just added it across, right? So I have 5, 6 plus 5, 6 is equal to what? 5 plus 5 is what? So then can I only get one whole out of it? I should only get one whole, right? I have one whole at least, right? I have one whole and then I subtract 10 minus 6 to get what's left over. What's left over? Can I leave it as 1 4/6 though? What do I need to do? What happens whenever I have a number that I can do what with? What's it called? Begins with an S or an R. You can use either one of those 2 words. Nope. Reduce or simplify. Use either one. Simplify. So what if they're both even numbers, I can divide by what? If there's two even numbers, I can divide by what? 2. So I'll divide both my numerator and my denominator by 2 to simplify it. 4 divided by 2 is what? 4 divided by 2? 2. And then 6 divided by 2 is, so I get 1 2/3, which is my final answer. Remember, you need to remember to reduce or simplify. If you should be able to look at the numbers and determine whether you need to simplify or not. How do you know if you need to simplify? Who can tell me? How do you know you need to simplify? Lexi. So it means that both numbers can be divisible by a number. If they're both even, then more than likely they can be divisible by 2 at the very least. So if you have two even numbers, then you need to make sure that you get to an even and an odd number. Okay? And from there, anything other than that, you need to look. So if it says 3, 6, you need to know we're going to divide both of those by 3, right? Make sure that you're paying attention. Okay? So let's look. So they already have, I'm not going to do that. I want to do the word problems. Good. So Carla mixes vinegar and baking soda for a science project. She uses a spoon that measures 1/4 of a teaspoon. So 6 times. How much baking soda will she have? You can present this in a couple different ways, right? So the actual problem is 1/4 times 6, right? That's my problem. I'm trying to figure out 1/4 times 6. Would you like to lose your privileges to use them? Put it down, please. We're not using them right now. Thank you. Okay. 1/4 times 6. So I see this, and I'm going to represent it in some sort of way. So what is one way that I could represent it? I could use what 2 ways? We've used 2 different ways. What are they? I could represent it using, what's this called? Maddie. Well, not what is this called? A fraction strip or a fraction bar. I can use fraction bars, or I can do what? What was the other thing that we used? Counters, but I'm in this case today. I'm talking about today. I have fraction bars and what? Fraction circles. So just depending on what I feel like the circles make more sense to me. Do the fraction circles make more sense to you? Okay. I like them better personally. Okay. So whenever I'm representing it using a model, like I'm asking you to do right now, I want to represent 6 circles that each have 1/4 in them. So I'm gonna draw 6 circles, 1, 2, 3, 4, 5, 6, and then I'm going to split them into 4. And how many fourths will I shade in each of them? 1. Shaded 1/4 in each. So if I have 1/4 6 times, right? Do I have at least one whole, do you think? Yes, how do I know that? Well, 6 is greater than 4, right? So I at least have 4, right? So 1, 2, 3, 4 gives me what? 4 gives me one whole, right? And then I have how many left over? So I have 2/4 left over, which is equivalent to what, y'all? I can divide these both by 2 and get 1/2. You should already know that. That should be a common, quick, easy thing. You shouldn't have to write it out. But the answer is 1 and what? 1/2. It was an answer. Okay. So now number 6. I like this one because it already gave me the fraction strip, so I don't have to think about how to represent it. So I need to just determine what it's asking me to represent. So remember, the top numbers up here represent what in my problem? The 4 1-holes, what do they represent? What number in my problem? What do the 4 1-holes represent at the top? Think about the problems we've already done. What is it? It's just the what in my problem? Lexi. The top numbers. This represents what? It represents the whole number that I am multiplying by. Does that make sense? The whole number that I am multiplying by. So in this case, it is 4. Now I also need to determine what my denominator is. So how did I determine what my denominator is earlier? I did the opposite earlier. My total amount of pieces here is what? Equal to my what? 8. Peyton. It's my denominator. So how many are there? 8. 8. And then whatever is circled is my numerator. 3. 3. So my number sentence is 3/8 times 4. Which one is that? Better choice what? You have to be able to recognize the pieces of the fraction strips and how we got it there. Okay, remember, on your this problem right here is what you will see on your test. Okay, this is the type of representation it shows. It says, how do I find the multiplication problem it represents? It's not asking you to solve it. It's asking you to do what? Recognize the pieces. So the top bar is my whole number. The amount of fraction strips is my denominator. And then lastly, my circled information is my numerator. Like I said, I will make a anchor chart explaining this in detail, ladies and gentlemen. Okay. So last one. Josh brought 4 small Finnish pies to his team party. At the end of the party, 3 pies were left. Josh gave 2 whole pies away. What part of the pie did he have left to take home? So first of all, how many did he start with? How many did you start with, Maddie? 4. So I'm going to start first by having 4 circles. That's what I split up into. How many pieces are going to be on the pies? How many pieces on the pies, y'all? It's my denominator. How many pieces on the pie? Maddie? 5. So it's going to be kind of a weird one to do. So you're going to kind of have to do a 8 by 1, 2, 3. Doing 5 is like the worst thing. It's like it's a weird amount. Okay. So then I color in how many on each? How many do I color in on each? How many fifths were there left? How many? It's the numerator. What's the numerator? Bella, what's my numerator on this problem? On number 7, what's the numerator? 3. So I'm going to shade in 3/5 on each of them. So now I have 3/5 on each. I'm going to write them underneath and find out how much was left. So 3 plus 3 is what? 3 plus 3 is what? 3 plus 3 is what? 6 plus 3. 9 plus 3. 12. So I have 12/5 left over. So how many holes do I have? Because that's an improper fraction. How many holes? 2, right? Because I know that 5 can go into 12 2 times. How many is left over if I subtract 12 minus 10? So if he gave 2 whole pies away, how much was left? 2/5. I subtract 2, I get 2/5. Okay. We're going to make an anchor chart together real quick on this information, okay? So you need to have your spiral out real quick. You can use colors if you want, but it's not necessary, okay? But I want to do it together. And I'm going to pull out my notebook so that y'all can see it on my notebook. Wait. I'm not sure yet. We're doing an anchor chart first. Ooh. Notebook out. I'll just do that. Okay. Press page. I cannot hear talking. I cannot hear talking. Hey, at the top, I'm putting. I am writing multiplying a fraction by a whole number. Who do I want? Let's look at the board. Can you wait just a little bit? One second. You are not talking while you get this answer. So we're going to use a couple ways. I'm going to show you a couple ways of how you can do this. One way is through doing the model, right? Okay. One way is using a you can use a number line too. Okay. However, that's not tested, so I'm not gonna write it for you. I'm gonna show you what we did in class today. So using the fraction strips, and I'm gonna do fraction strips, and I'm gonna do the circles. Okay. So I'm gonna write underneath it, but I can multiply a fraction by a whole number using models. So one example is by doing fraction strips. So I can use fraction strips in order to find my answer here. Yes, sir. Yeah, Mom, could you please turn off the letter? Voice. So I have fraction strips. So what I'm going to be solving is 3 times 2/3. Okay? I'm finding what 3 times 2/3 is equal to. So using my fraction strips, the first thing I do is I use my 3 wholes. So I'm going to go ahead and make it nice and big so that it's easy to look at. And I'm going to have 3 1 wholes. Because the holes represent what? What do the holes represent? It's as simple as what? It's my whole number. Now I need to find something to go underneath here that I can split into 3s. And you have 3 groups that will be equivalent across here. What would be? I can put 3 of them underneath, and that would be equivalent. I'm not sure the bad number. What do you think? Well, a half would be too small. Another hole. If it's too small, then I think I put that on this. I used the one that I had on my other thing. So let's do. I'm gonna change the numbers. I'm gonna do. I like this one. So I'm gonna do. So I need to find. So that divided the 12 right here. 12 pieces. Okay. Oops. That would mean that there are 4. I don't know why you're talking coming from over here right next to me, but it should stop. Unless we'd like to lose recess tomorrow. I put 1/4 underneath. So the amount of fraction strips is given by what? Look at my denominator. I want you to recognize this and see it. And the denominator is how I find how many pieces go underneath it. And then lastly, how many do I circle of these 4s? How do I find that number? How do I find how many I circle, guys? My numerators. And that color, I'm trying to show you, I am color coding it, so if you would like to color code it, you can. So I circle 1, 2. 3, 4, 5. So that means that my answer is what, ladies and gentlemen? I have one whole and 1 fourth is my answer. Please. Okay. So the second thing I'm going to write out is I'm going to do the circles. Okay? So fraction circle. So I'm going to use that original number from earlier that I started with, which is 3 times 2 thirds. Equal to what? So knowing that, so what do I start with? How many circles do I have? How many circles do I have? Total. 3. It's as simple as that. I have 3 circles. Number of circles. Then this is how much is shaded in each circle. And the 3 itself is how many pieces in each. So I'm going to divide it into 3 pieces. 1, 2, 3. 1, 2, 3. 1, 2, 3. And then I will go back and shade my 2. Two thirds plus 2 thirds plus 2 thirds. So I have 2 plus 2 is 4 plus 2. Okay. So I get 6 over 3, which is equal to what? Can I divide evenly? So I get what is my final answer? Now 2.5. It's 2. Because it's final dividing. So 6 divided by 3 is 2. You can also do it differently. You can represent it another way would be so you can do it on there if you want to. So I could do something similar to this exact same thing, but instead I use I can draw it like this. So I have boxes instead, and I break them up into thirds. And then I go back and I shade 2 thirds of these. Really can come in all forms. That's just another example you could do. Really, there's so many different ways to represent multiplying a fraction by a whole number. So you can use fractions, you can use fraction circles, really use any kind of shape and do this exact same thing where you break it up into the pieces and then add them up. Yes, Melanie. The 3 ones, where's that? In the fraction strip? There's a 1/4. Okay, that is where I'm ending this.